Hello and welcome to the Online College of Coding video tutorial series. This is video 2 of the series on creating Squirty Squid at intermediate level using Unity and the C# programming language. In this video we'll be looking at writing the rest of our C# scripts to complete this Flappy Bird clone game. Before starting this video, it's recommended that you've completed video 1 of this series. So, if you're ready, let's get started. So, you may have noticed at the end of the last video that by colliding with our obstacles, nothing happens. So let's make something happen if there is a collision. To do this, click on your player, and over here add a new component. We're going to be adding a box collider 2D. So if you start typing that in, we choose box collider 2D. Now we need to add a collider as well to our anemone pair. So in our prefabs folder we can see our anemone pair, and if we click on the little arrow here, it will expand the anemone pair to show the two constituent components. So selecting one at a time, we want to add a new component to it as well, but this time we're going to be adding a polygon collider. So start typing polygon collider and select it here. After you've done it to one, do it to the other. And now if you test your game, and if we deliberately collide with one of the obstacles, you can see that it collides. So now we can use the fact that Unity is detecting these collisions to make the player die when those collisions occur. We do that by modifying a few lines in the player script. So open that now. Firstly, we create our new die function, which when called causes our loaded level, or single scene in our case, to be reloaded. Then within our update function we have a game constantly checking if the player has moved outside the screen. Firstly, we create a new vector2 called screen position, and that is assigned the value of the player's transform position relative to the main camera in that scene. Then we use an if statement to check if the player's screen position is too low by checking if its Y value is more than the screen height, or too high if it's less than 0. This may seem counterintuitive until you remember that the 0 point on a screen is in the top left hand corner. If either of these conditions are true, it will call the die function. And finally, we've created our own function called onCollisionEnter2D, which simply calls the die function if any collision with the player is detected. So run your game now, and two things should happen. Firstly, if you go off either the top or the bottom of the screen, your player should die. And secondly, if you collide with one of the objects, your player will also die. In both instances, when you die, the game restarts. So our obstacles now do half of their job. They create the challenge within the game by providing something to collide into. So now we need to add their second purpose, which is to provide a score if we manage to jump through the middle of them. To do that, we need to create a new script called score. So within scripts, right click and create a new C# script and call it score with a capital S. Double click on it to open it in MonoDevelop. After removing both the start and update functions, firstly we declare a new variable called score. It is an integer data type and is assigned the value of 0. Then we create a new function called onGUI. It is of data type void as it does not return any value. It simply performs actions like setting the color to be used as black and displaying a label called score. The section of code of +score to string converts the current score value from an integer to a string and displays it as part of the label. And finally we add a new function called addScore, which when called will retrieve the current integer value of the score and augment the score by 1. It then updates this to being the new integer value of the score. This is called the increment operator, and this syntax is common to a number of programming languages. If it had score minus minus, that would decrement the score by 1 instead. Now, remember that to make a script work, it needs to be attached to a game object within the scene. Now to do this, we're going to attach our score script to the empty game object called scripts that we created earlier. So click and drag your script up onto your scripts object. Now you can have a look in the inspector and you can see that our empty game object called scripts has two components, one called generate and one called score. However, we're not ready to start scoring yet, because if we have a look inside our score script, you can see this new function called addScore, but nothing within that script actually calls that function of addScore, so we need to add some more lines of code. We're going to do that within the player script, so open that and add the following lines of code. Firstly, we declare a new variable. It is a data type specific to Unity of type GameObject, and its name is scriptsObject. You should recognize this as the empty GameObject we added into Unity earlier that we called scripts. In Unity, we've already added the generate and score scripts as components of this GameObject. Then we've created a new function called onTriggerEnter2D. This is a built-in function that Unity recognizes. This function will automatically get called if a trigger event is detected, in this case with the Collider2D as part of another GameObject. We will be configuring this trigger to occur when the player collides with the box collider, which is part of our anemone pair prefab. Within this new function, we then use an if statement to check if the other object that the player collided with was indeed the anemone pair. Clone refers to the fact that each new anemone obstacle is a clone of the original prefab object. So, if this is true, it then gets the component of score from the scripts object, which is itself another script, and calls the function addScore from within that script. It then disables the box collider as part of that object so that it doesn't keep registering collisions and keep looping this function over and over. Now, before these additions to our code will actually work within our game, we need to make two changes within Unity. The first change involves this declaration of this variable up here. We've declared a new variable called scriptsObject, and so we need to tell Unity what this scriptsObject is. So if we return to Unity and select our player object, looking inside the inspector in our player script, we can see a new scriptsObject here. We need to tell Unity what this scriptsObject is. So from the hierarchy, click and hold and drag your scriptsObject all the way over into there and let go. That will now make the association between the declared variable and the scriptsObject. The second change that we need to do involves our prefab of an enemy pair. Remember that within that we have a box collider, and this is the thing that is detecting whether or not your player has managed to jump through the center of our obstacles. For this to work correctly, we need to find this part here which says is trigger and tick this box. Now if you test your game, and if you safely navigate through the center, you can see that your score is augmented by 1 each time we manage to jump through the obstacles, and that's because the player is colliding with that box collider which is in between but hidden from the player's view. So our game's looking pretty good, but we want to add some polish by making our background scroll to further add to the illusion of our player moving. Now we need to turn our existing background into a textured game object. Select the existing background in your hierarchy and delete it. Be very careful that you don't delete it from your textures folder down here. And in the hierarchy, create a new 3D game object called a quad. And in the inspector, rename that to background. Now set the transform position for this quad to 0, 0, and 10, and its scale to 20, 10, and 1. Next, we need to select the background texture object from within the project view and change its texture type to texture and change its wrap mode to repeat. Next, we want to get our background game object from the project view and drag it from here up onto our background quad up in the hierarchy. Next, select your background object from the hierarchy view, and over here change your shader from standard to unlit transparent. Now we need to create one final script that will make our texture object move. So create a new C# script and call it scroll with a capital S. Open this new script to edit in MotoDevelop, and to this script we're going to add two new variables and a couple of lines of code to our update function. Two variables are declared first, a floating point variable called offset with the value of 0, and a second floating point variable called speed with the value of 0.001. Then within the update function, it sets the value of offset to being equal to offset plus speed. Then, because we're going to be adding this scroll script as a component of our background quad game object, Unity retrieves this game object's mesh renderer component. From within this, it gets the texture offset on the material, which in our case we've set to our background art, and sets it to a new vector 2, with its x value being equal to offset, which in turn we know has been set to the value of speed. Speed is a public variable, so we can modify it within the inspector if we want to adjust the pace at which the background will scroll. Now for this to work, we need to apply our scroll script to our background game object. So get your script and drag it onto your background. Your game is ready to test, but before we do, click on the Game tab and change the aspect view here to 16 by 9. And if we test our game, now if we crash into our game objects, we die. If we jump through our game objects, we score points, and our background and anemone are scrolling beautifully. And that completes this intermediate level tutorial series on creating Squirty Squid using Unity and C#. If you feel you're ready, you can progress to the advanced Squirty Squid tutorial series, where you can learn some more in-depth programming and Unity skills and create an enhanced and more polished version of Squirty Squid. Alternatively, you can progress now to the tutorials on how to export your game to be played on a PC or Android device. Meanwhile, congratulations on completing this intermediate level programming course.